From. Welcome to today's Tech Talk. Today's part of the Tech Talk X series by Digital at INSEAD, which is dedicated to exploring new technologies as well as considering their implications and applications in business and in society. Before we start, let me do some housekeeping, where I demonstrate the webinar etiquette for question asking and so on. So the audience will be muted throughout with the video off and the chat is closed. But in order to communicate questions, you can submit them through the Q&A tab. As well as once a question has been submitted, you can choose to vote this up or down. And I believe our moderator, Robin, will be looking primarily at those questions that have been voted up more. So if you want to make sure that something is answered, please make sure to click on it there. If you have any technical issues, there's an email here, digital@insead.edu. All right, I will now share my presentation. Okay, so the topic that I'm going to be talking about today is large language models and their insights into global attitudes. But before we get underway with considering my research and actually how I use these large language models and different forms of analysis to understand attitudes and decision making, I wanted to start with a brief overview of methods in the field. So I think this term LLM emerged around about the same time we saw ChatGPT, and now we hear LLM, large language model, all of the time, but this might be a little bit disconnected from the history of how these techniques have developed, as well as from some of the technical elements that underpin them that are actually quite important to making sure that we can be informed consumers of this content and engage effectively in this discourse. So I want to trace the history of text analysis back to the 1940s. Where an Italian priest called Robert Bucer did arguably the first version of natural language processing, where he just manually counted what words were used by Thomas Aquinas and in what contexts they were used. He ended up collaborating with IBM on some of the first automated text analyses, but really the history of NLP can be traced more or less back to this point. But so in the 1950s, they built on this approach with something called bag of words, which has then been used in many different innovations since. So if you've ever heard this phrase and not quite known what it means, I just wanted to take a moment to explain. So what a bag of words does is the following. We take a sentence like a man kept walking where he was walking. And now rather than maintaining its order and its contextual factors of how this language was used, you just break it down to a table. Where we can see there's a column here for every word, a, man, etc., and then a column for their count of occurrence. So here every word is used once, except walking, which occurs twice. There are various variants of this, such as you can just have did a word occur at all or not. But this underlying representation of a body of text was the predominant way of treating language for many, many decades. So it answers questions like what words occur and how frequent are they? But of course, critically, the philosophy underlying this is that the order in which they're used does not matter. It's not that linguists at the time actually thought this was true, but just for lack of more sophisticated or complicated methods, this was how text had to be analyzed. But there are many interesting things you could do with this. So for example, this table alone is maybe not informative because we don't know if this is an unusually frequent amount of time to be talking about walking or not. So you can do things like comparing this to other documents and see, are concepts like man and walking talked about an average level here or more than in other comparable documents? But this bag of words approach was really what was used for many decades. In the 1990s and 2000s, we saw these great innovations in how we could treat these data. So if you've ever heard of latent semantic analysis or LSA, and LDA, or what we might call topic models, but they're still operating from this fundamental context-free approach to language, where you express language in these tables, and then you estimate models to somehow try and understand the meaning of what was said. But as we turn to today's modern LLMs, there are really two dates that are very important to know. The first one is 2013, where Google introduced this algorithm, word2vec. This was originally meant to help with automatic translation, but as it turns out, it's helpful in all kinds of different ways. So I'm going to take a moment to explain this a little bit. Essentially, the Logic underpinning this is captured by this quote from the linguist Firth in 1957. You shall know a word by the company it keeps. So if we imagine we have some sentences, pardon me. If we imagine we have some sentences like the following. Now, when we need to learn the meaning of the word she, we have to look at the context in which it's used. So, for example, we say, here's the first occurrence of the word she. All we're going to try and do is predict what word is in that position from the words that are around it. So you can cover up that word, and using the words before and after, so what a leader and was incredible she, you try to predict what is the word in that missing gap. And you do this across many different occurrences of when the word was used. So this is just one case. Here's another one, where now we're trying to predict what is that blanked word from the words around it. She was incredible and acted with independence. So the mathematics of it are a little bit complicated, but if you hear this term word embedding or word to vec, what I want you to think is at some point they were trying to predict those missing words in the middle with the words that occurred around them. The end result of this is you end up with these high-dimensional vector representations of the meaning of each word. Now, this can be a little bit complicated to wrap your head around, but essentially, the way to think about it is when you solve that optimization problem of trying to predict that word in the middle from the words around it, it ends up being useful to have numbers that represent each word. So these can be vectors, for example, commonly used numbers of dimensions are 100, 300, 500, where we then have that vector, which is just a set of numbers that captures the meaning of each of these words. So in this example, man, woman, independent. Now, these vectors are interesting because they richly capture the meaning of those words across many different dimensions. So rather than just a few that we can manually quantify, hundreds of different dimensions that help us to understand really how is it that these words are used. We can then do things like the following, where we look in vector space, how close are those vectors together, as a means to understand whether there are things like gender bias in the language that was used to train these models. So this here is just a simple 2D representation of these types of embeddings, where if we see that the vector for man is closer to the vector for independent than the vector woman is close to the word independent, we might say that there's this gender bias, that in the training corpus used to estimate this model, men were more often discussed as independent than were women. And I've used this elsewhere in my research, so I'm very lucky that this is my second time talking in the Tech Talk X series. The previous time I talked a bit about this research, where actually I looked at how does hiring a woman as CEO change how we're using these words. So along the x-axis here, I have how much a word shifted towards the meaning of being a woman. We saw that when you hire women as CEOs, people start discussing women in general as being more direct, determined, independent, active, all these type of positive traits that we might associate with positive agentic leadership. But today we're going to be talking about something a bit different. So the first date that I want you to remember when thinking about LLMs is that 2013, where we had the advent of word2vec. But the next big update, and the one that really sort of lit the fire under all of the advancements we see today, was 2017, 2018. So in 2017, a seminal paper was published on the importance of attention in these models. And 2018 was when we got the first real transformer models, things like BERT from Google, as well as the original GPT. So what does a transformer do? That is the T in GPT. So this is something you're unwittingly engaging with, even if you're not aware of the technical concept before. It helps us to do a few things. So if you imagine I take those sentences I had before, but now I put them all together. So aside from the crime against grammar that I've just committed, what we end up with here is a long sentence. But now just looking at that narrow window around each word can end up missing nuances in the meaning. So what a transformer helps us to do is look at a much wider context to make sure that we really understand the meaning of a whole sentence or a body of text rather than just those individual words. So the key advancements really are the following. One, the words can mean different things in different contexts. So if you just have a single static word embedding, consider something like the meaning of the word fair. Fair can mean things like just and equitable. It can also be a sort of party, a thing you go into the country with your family, or it can mean something like beautiful. And if all of these have to be represented by a single word embedding, you can get sort of mixed up with the meaning of that. Whereas transformers allow it to be the case that each word takes on a different meaning depending on the contextual words it has around it, which really helps us to get around this problem. But the second thing, and the really key thing that has made LLMs able to respond to questions from humans with just incredible accuracy and competency, is the idea that if you take an entire sentence, it's difficult to work out which combinations of parts in it really drive that meaning manually. And if you just compute all of them, this is very expensive and you can get into overfitting. But what a transformer and this attention mechanism allows you to do is work out which parts of those nonlinear combinations of particular words in the sentence are really important to communicating its meaning, which means its ability to capture the meaning of longer sections of text is just much better. And if you hear this idea, what's the large in large language models? Is if we go back to 2018, this is to do with the number of parameters. The original LLMs were maybe 100 million parameters. You fast forward to sort of 2021, got up to 100 billion. So very quickly, they've increased in size by 1,000 times. And indeed, some of the more recent models are getting towards 500 billion, even 1 trillion parameters before people kind of slowed down and said, well, is more always better? Can we do this a bit more efficiently? But the large is really just to do with the number of parameters. If you think about something simple like linear regression, you have 5 inputs, you have an output, you have a single parameter for each. Now you have all of these many millions of parameters to make sure you can get all of the information out of these inputs to really be able to solve your complicated tasks. So the key methodological points just from this quick little review, apologies if you've heard these things a lot lately, but just to make sure we're all on the same page as we go forward. For understanding the meaning of individual words, word vectors are really important. They represent the meaning of those individual words pretty effectively. If all you care about is single words, even the more modern models, transformers, LLMs, these different things, you're not going to get too much extra juice. But if you want a larger section of text, if you want to understand the meaning of a question posed to ChatGPT, you really need this transformer architecture to make sure you understand what parts of the sentence interact together to effectively communicate a meaning. This kind of technical basis aside, the main topic of today's talk is going to be how do these LLMs, how do these methods encode biases as well as attitudes? And what do we need to do when we think about this? So if you see this case, this is a case of algorithmic bias in that the LLM has encoded that men are more independent than women. Originally, when people first introduced these types of methods, people thought that this wouldn't emerge. But then we later come to realize all this is doing is representing the training data that's given to it. So it isn't that this algorithm is sort of nefariously doing something, it's just holding up a mirror of society and specifically of the corpus it was trained on, which means if you were trained on something that says a man has to be independent, being independent is more important to a man, a woman has to be intelligent, being intelligent is important to a woman. If this was your corpus, you would have this gender bias towards men for independence and a gender bias towards women for intelligence. But so what do we have to do about this? Before, when it was only people who were deploying these models off the shelves in specific applications, maybe we could really see the implications of these different behaviors and think about how to debias them. But we've moved into a world where the entire world has these LLMs at their fingertips to immediately deploy them in different tasks in their professional lives and their personal lives, which makes this question of algorithmic debiasing more important than ever, but also more complicated than ever. So the first option we have when we face these cases of algorithmic bias is do nothing and let the model be a mirror of life. And so Google's Bard tried something like this, and without too much fine-tuning of the model, they produced this chatbot that would readily reproduce misinformation. Things like chemtrails are real, some conspiracy theories about the conflict in Ukraine. And this is just one model, which at first glance seems perhaps to be ridiculous just to leave everything in there, though in a second we'll discuss how it's maybe not so simple. Because the alternative is you change elements of the models arbitrarily. So when I say arbitrarily, this sometimes has a negative connotation, but that's not what I mean. It's more to say there is no systematic set of principles that dictates what biases we need to take out, where, and why. It's more some social planner has to make that decision about how to change the model. It turns out to be really hard to do that in a way that's principled, in a way that everyone can agree on. Indeed, perhaps impossible to do in a way that is universally accepted, as we'll see in a moment. And so the classic example of this is something like the Gemini language model, where people were asking for portraits of the founding fathers, and they were ending up with these different pictures that showed people of different races to the actual founding fathers of the United States. It turns out this was because the model was interjecting an intermediary prompt, where if you ask something like, please give me pictures of the founding fathers, it was transforming that by adding on clauses saying, in a sample that is ethnically and gender diverse, something like this, and then producing the output. So we see this was projecting some social values from that private company, Google in this case, that modulated the outputs that people see. And so working out what to do in these situations is really non-trivial. In the work that I'm discussing today, I don't claim to have solutions yet. I'd argue this is one of the most important questions facing society today, but we can at least try to cultivate some awareness. And so there's a couple of things that I want to draw your attention to here. Is right now, at least in the communities that I'm in the research communities, there's a lot of hysteria about rather than training your own models and really learning to code and doing all of this technical and difficult stuff, you can just use ChatGPT. Because these foundational models, these things like GPT-4, are just incredible in terms of their performance on many tasks. Which means trying to start from scratch and build your own thing is not only very costly in terms of training and time and so on, but it might just be ineffective in terms of your solution. That is fine, and there's a strong economic case for that. But you have to accept that doing this is explicitly accepting the bias adjustments that have been made by that specific private company. So if you take OpenAI, there's just a private company that talks as if it has some mandate to society, but it's not technically true. And so they've taken a model that was just the mirror of society with all of the bad things that are contained in that. And then they've manually and arbitrarily adjusted specific aspects of that so the model behaves in ways that they find palatable. But what's the cost of that? Is even issues that feel unambiguous. So if we want to take out things like gender bias, for example, one of the computational methods by which people take out gender bias is if you have a text that says, he is independent, and you want to make sure that the model doesn't learn that men are more independent than women, every time that happens, you can synthetically create a sentence that says, she is independent. What does this do? It means you end up taking out those aspects from how it's learning meaning. Of course, this has some advantages in that it may not readily recreate some gender stereotypes, but it's not without costs. It can be that this feminine identity that is then scrubbed from the record can be important to particular people. There's all types of different examples of this where it's difficult to work out what should we leave in and what should we take out. And indeed, when we think of the sort of political polarization, so I also do research on misinformation. We see things like the Republicans and Democrats in the United States are working from completely different ideological positions that also rely on different information sources. Which means if you end up having these models, so made by people like OpenAI, they've been shown to have liberal biases, in that if you really drill in and you really sort of cleverly navigate the fact that the model tries to say, I'm a model, I don't have opinions, if you manage to overcome that, you can get the models to say that guns are bad, abortion is good, and these types of different things that are fundamentally liberal viewpoints and not universal truths accepted by all groups. If this continues to be the case, there will become a market for other people to have their own models with their own ideological slants, which anything will happen in the free marketplace, but this runs the risk of further ideological divide as people depend on different models that can sort of pander to their own belief systems. So this is a big risk we have going forward. But the foundational question that I want to address today, and what I've looked at more in my research, is what attitudes is it that the models actually capture, and what do they tell us about humanity, human beliefs? So this is research with colleagues. This is Sally Fires at INSEAD, as well as Donny Goya-Tiketo at SUNY Buffalo and Keith Payne at UNC Chapel Hill, where we have this project looking at global attitudes about inequality from this large language model NLP perspective. What is it we can learn from the models themselves, and how does that correspond to other sources of information like survey data? So the data that we use for this are word vector models. So without transformers, because we're going to look at individual words, word vector models for 157 different languages trained by Facebook using data from Wikipedia, as well as Common Crawl, which is a large archive of data from the internet, 250 billion web pages. Is trained with an algorithm very similar to Word2Vec. For all intents and purposes, just think back to that slide where we showed that moving window, where we've got to learn the meaning of the word in the middle from what's around it. The two foundational tasks we were faced with when starting this research project are how do we define these attitudes? What are the attitudes that are actually important here? As well as how do we translate across these languages? Because we had to automate this. In practice, this took the majority of our time, or I should say Saleh's time, as he was really superstar in leading this project. But I'm going to gloss over some of those details to focus more on the theoretical takeaways that we can learn here today. So we ended up having 7 different categories that were based on research in the area, psychological theory, and so on. The first big one is this idea of individual attributions. So a lot of the psychological research on attitudes about inequality is conducted in the United States, which is a very individualistic society. And so the idea that inequality comes from some people being hardworking, some people being lazy, some people being smart, and some people being not as smart. There's a lot of this emphasis on individual attribution. So rather than these systemic causes, actually just viewing inequality as coming from properties of the people. But there are other things too. So thinking about group-based disparities, what about the role of prejudice and discrimination in contributing to inequality? Some groups are just systematically excluded, which drives disparities between groups. As well as things like, what about the relationship between inequality and fairness? Is it that inequality is fair or unfair? Is it that there's just no relation and these are just different ideas? We also looked at education. So how does education relate to how inequality develops? As well as luck, is it just that some people are unlucky and that explains a large amount of differences in terminal resources? As well as crime and economic status. So is it the case that inequality is really about the rich getting richer or poor people not having enough? These were the 7 buckets that we looked at. And we next had to think about how to study them in languages across the globe. So if you imagine, take a word here, loyal, in English. We now had to translate this to as many of these 157 languages as we can. I think in the research team, we speak English, Farsi, French, and Portuguese, but that's where we're done. 4. We didn't have 157, at least not yet. If you think of the word loyal in English, in French, it has many different translations. So things like loyal, dévoué, fidèle, loyaliste. There are many different options here, and now we have to kind of pick what is the word that we're going to hold up and use as the representation of that word in this new language. The details of this are quite complicated, but I just wanted to show you a little bit. Essentially, when you make calls to Google's API, you don't just get one translation, you get multiple, as well as how frequent they are. So in pairs where this word, loyal, was translated to fidèle, turns out that was the most common. In most translations, that was the mapping that was done, and the others have their associated translations. So it could be that there's a word in French that is a great translation of loyal, but it's just not very used. That would then not be the right vector to capture that meaning, so it just wouldn't be the one that people are actually using. So you get all of these different translations, and then essentially we ranked them in order of this frequency, and then you can do something simple like just taking the most frequent translation, or you can weight all of them to get some kind of average, and you end up with these different vector representations of the word now in French space. So if I take this word loyal, I have a vector for that in English space. I think it was 300 dimensions. I want to end up with a translation in French space that is also a vector of 300 dimensions. There's a few different ways we can do this. But so we took our 157 languages. We were only able to use this Google Translate API for 93. We then made sure that we had enough data to really be sure that these were well trained and represented a reliable estimate of that language rather than sort of noise through not enough data. And then we ran a validation that's common in the literature where you check if positive words in that language are not strongly associated with words like good, then you take that somehow this vector representation of the language is not accurately capturing features of the language, so you probably shouldn't be studying it in this way. So we ended up with 48 languages where we were able to look at the relationship between inequality and all of these 7 different buckets across those languages. And all we're doing is this. If you think of this 2D representation, we're looking at how close is inequality to something like fairness versus how close is inequality to something like crime. We end up getting these numbers. These are just cosine similarities, which represent how similar is that vector. We end up with this huge table. Don't worry, I'm not going to ask you to look at all of it. But on this y-axis, we have all of these different languages. And on the x, we have the association with each of those features. So there are these 7 buckets, things like fairness, things like luck, and so on. We get numbers for all of this, where blue indicates a relatively stronger association, all the way down to white, which says that inequality is no more strongly associated with that concept than it is with a random set of words. We standardized it in this way because otherwise you get confounds with different properties of the language. But if we zoom in on a few things here, the first thing to note is that inequality is more related with some features than others. So people saw inequality as very related to fairness on average, and less related to things like education, and surprisingly, these individual attributions. We'll come back to that more later. The next thing to note is if we take within a particular feature, so I've just taken a subset of that graph, consider group-based disparities. Here we see that in Russian, compared to Slovenian, group-based disparities, so that thing like prejudice and discrimination, were viewed as approximately twice as related with inequality. And we'll come back to what does this mean? We're seeing these differences across language, but what does this actually capture? What is it that we've zoomed in on with these AI models? What does it tell us about how people think and how people feel? But we can go a bit further. So we have these 7 different buckets. But is it that these 7 are separate dimensions and we don't really see how they fit together? Or is it the case that there are distinct clusters of beliefs that capture worldviews about inequality as a construct, meaning that these are highly correlated? So it turns out that that is the case. So in languages where you viewed inequality as related to economic status, so being rich and poor, you also tended to view it as related to group-based disparities, so that discrimination and that prejudice. We see some weaker relationships where, to some extent, whether you viewed inequality as related to education or not, wasn't really related to other sets of beliefs. But we see clear evidence that these types of beliefs hang together. As you either view inequality as related to luck, as related to fairness, as related to individual attributions, or you don't. But we can go a bit further. So given the fact that we have these systematic ways in which languages tend to express inequality, we can actually cluster languages based on those sets of beliefs and see, can we kind of see some evidence of cultural beliefs that map onto something geographic? So on the next slide, I'm going to show you a map. It turns out when we do this clustering, these very clear geographical clusters emerge, where we've got essentially 3. One is this green. This captures sort of Romance Western languages, so things like Spanish, English, Portuguese, and so on, as well as some other things. I think this is India, yeah. And then we get this is the green cluster. And then we get this red cluster, which is capturing Russian and other Eastern European languages, and to some extent, Northern European languages. And then we get this blue cluster, which has the Middle East, and we can sort of see this belt running through here. So just based off properties of these languages, we can see 3 distinct sets of beliefs about economic inequality and its relation to these other constructs that really map onto areas of the map, for a terrible pun. But can we go a bit further and kind of try to characterize these clusters? So if you remember those colors, red being that sort of Eastern European, blue being that Middle Eastern, and green being the sort of Western Romance languages cluster, we see actually that they systematically differ in the beliefs about inequality that they espouse. So in particular, you can see that in that Middle Eastern Asian cluster, these languages tended to view inequality as more related to luck and more related to crime and economic status than did in either of those other 2 clusters. So we'll take a minute just to pause and think about what are some intermediary conclusions that we've been able to make just from these languages data. So we see that across the globe, inequality is consistently associated more with some concepts such as fairness than others such as education. This just shows there is some stability, some consistency in how people tend to characterize inequality, even across this disparate and very broad set of languages. We also see that there's this meaningful variation within each feature. So if we take a given aspect, so the association of inequality with group-based disparities, you can see a stronger relations in some languages than you do in others, even ones that might be somewhat culturally similar. We saw that these attitudes hang together. So we saw those positive correlations showing that a country that tends to discuss inequality as related with fairness would also view it as related with something like group-based disparities. And finally, we saw those interpretable clusters of countries, where it really appears that we're detecting something meaningful in the language. But the next question is, what can this tell us about culture? So if we come back to this example, this looking at how Slovenian and Russian have different associations with this group-based disparities bucket of words and this inequality bucket of words, what does this actually mean? If we think about those word vector models, those are just trained by what words tend to co-occur. It's not about people thinking per se. It's about how people talk in those languages, about a whole different set of issues. It's not that we're asking people to talk about inequality. This is just trained off web pages and off Wikipedia. So we see all instances where these words that we're zooming in on are used. How do people tend to use them? So we've got this evidence that these patterns of co-occurrence seem to vary across languages. But we next want to think about, does this say something about how people think or how people feel about inequality? For that, we combine these data with survey data. So we took 150,000 observations from 37 countries over a 30-year period. These data are very rich. So in addition to the survey items about inequality that I'm going to show you in a minute, they also have a lot of information about the people who were actually responding. So these are paper and pen surveys. Someone is on the ground in Poland asking people their views about various social issues, as well as capturing information such as their sex, their age, their education, and their relative income. All the types of things that you might expect would actually determine these attitudes about inequality. We merged these with country-level controls. So in addition to all of that information about those specific people, when we think about what country, what climate were they in, we have GDP per capita, the actual economic inequality is captured by Gini, population, political stability. There are many others as well. So we have this whole big set of controls that mean we think we can quite accurately capture both the national context economically, as well as that person's personal economic context. But we merge this with our word vector-based measures to see if can we get more explanatory power about those people and their beliefs just from features of the structure of their language, estimated with these LLMs, with these AI tools. So the way we combine this is, say you want to change from the French language to the country of France. You look at what languages are spoken in France. So majority French, but maybe some Italian, Spanish. And then you have these vector measures for France, Spain, Italy. You just weight them to produce that single measure for France. So here are the items that we have in that survey data. We're very lucky that they broadly captured different sets of beliefs about inequality. So here's one item saying income differences in this country, so Poland, for example, are too large. This just captures how do people feel about inequality? Are they concerned about it? But there's also all types of things, such as why does inequality persist? Is it because it benefits the rich and powerful? Is it because ordinary people don't push up enough against it? Or is it because it's necessary for prosperity? So these are three distinct sets of beliefs that capture someone's worldview on why we face this issue of inequality, or at least descriptively, we see inequality. And finally, we have also survey data on preferences for redistribution. So should the government do something about it? Should people with high incomes pay more tax? And should the government spend less on benefits for the poor? So here, what I'm going to do is compare two regression models. The first one predicts people's responses to this question, the government should reduce income differences, just using that information about the people, as well as that information about their country. So we explain about 14% of variance. That's pretty good. When we just add our linguistic features which capture properties of the language, nothing that this individual said. We have no more information about this individual, just properties of the language, of the culture that they are in. We explain more variance. So this movement from 14 to 16 probably doesn't blow you away. But if you think about it, a 7% increase in the extent to which you can explain variance can have huge implications when you're trying to predict the behaviors of these people. When you're trying to predict their attitudes, trying to predict receptiveness to government policies, and so on. The extent to which we can improve prediction, even in what may seem like incremental amounts, can have enormous societal implications. And in this is a 7% change, more or less. Across the different items, we saw 4 to 55% increases in R squared. So in how we could actually explain variance in those survey items. I really find this amazing that we have someone on the ground in Poland answering a question, and I can add value to how they think about these economic issues, these things about inequality, just by looking at properties of the language of Polish and rendering predictions from that, which really shows that these models are capturing something cultural, something important that really does affect the values, the beliefs that people hold. But we can go beyond this. It's not that we just have to look at variance explained, we can actually interpret this because we have those features, each of these 7 that are on the side here, and we can see how are those related to responses in each of these questions. So this is how are they related across a whole host of different analytical choices. We wanted to make sure that any effect that we reported was incredibly robust. So in any case where it wasn't robust across the majority or almost all of our specifications, we don't count it as a real effect. In practice, there are many different effects that turned up in some places and not others. These are just the very robust ones. So if you see that viewing economic inequality as related to fairness was associated with people being more concerned about that inequality. If we move to thinking about those mechanisms for why inequality persists, we see that that fairness variable is really flagging time and time again, as well as other things like viewing inequality as related with luck was positively associated with people thinking that inequality persists because people are divided and don't rise up to push back against it. And if we go to those last ones, these properties of redistribution, we see again that we get some explanatory power, we get some interpretable coefficients, that many of these different features are related to this question of whether the government should reduce economic inequality. So viewing economic inequality as related with economic status was positively associated with beliefs that the government needs to do something about this, the government needs to reduce it. Something important to note here, which I said I'd come back to, is that individual attributions did not relate to any of these 7 questions substantially, robustly. Because, again, I return you to the academic literature. The majority of theories developed in the highly individualistic United States and really emphasize these individual attributions and how people don't fight back against inequality or somehow feel dissatisfied with it because they make these individual attributions. We seem to actually see that on a global context, this is not what's driving people's attitudes. It's not what's driving people's preferences. And so it's a word of caution to focusing too much on one particular demographic and assuming that this is universal, which we already know from sort of literature on non-weird populations and so on. You can see it very clearly where we're able to work with a large range of countries and languages unobtrusively using these LLMs. They can help to contribute to some of that evidence on the importance of looking at these issues globally rather than in a fixed set of countries, particularly just in English-speaking countries. And so the theoretical insights that we get about inequality are the following. That there's basically 2 clusters of ways to think about inequality, to talk about inequality. If you understand inequality as related to group-based disparities, so that prejudice, that discrimination, and so on, these types of countries, the people who spoke these languages, in those countries, they've tended to view inequality as necessary for prosperity, as not a source that reinforces hierarchies, and they wanted the government to do less to reduce inequality. Whereas if you view inequality as related to this question of fairness and unfairness, the people who spoke languages that talked about inequality like that tended to be more concerned about inequality, view inequality as serving to reinforce hierarchies and not necessary for prosperity, and wanted the government to actually intervene and reduce inequality. As we zoom out to a higher level, this is my research focusing specifically on what can we learn about global attitudes on inequality from these LLMs trained in these different languages. The higher level implications are the following. LLMs are becoming a part of the fabric of society. We're now using them on a day-to-day basis. And such models represent words and concepts numerically as vectors. So we started the talk thinking a bit about those word vectors that underpin those models and where they actually come from. These vectors just reflect biases of the training data. It's not that the training alone can magically eradicate those biases. You should think of it as a mirror of society. And so we see that these vectors, as we displayed in my research, capture key aspects of language about social issues, so such as things of cultural values surrounding inequality, but also any other type of social issue that people care about will be captured in those embeddings. And what is captured in that language does actually relate to people's beliefs on those issues. And the implications of this are the following. The LLMs that we use are not value neutral. You can't take this voice that sounds very much just informative and just neutral and keeps urging that it's a large language model without an opinion. These are not value neutral. There's some mixture of a mirror of society and just holding up their training data, which tends to be the internet, which contains the worst areas of the internet, as well as these arbitrary changes made by these private companies who produce them, which both makes them very powerful tools to understand humankind, but also necessitates caution when relying on these outputs. You have to think, what is under the hood here? What data was this trained on? Do I want to recreate those patterns? As well as what changes were made by who and why? In my research, I do a lot of training LLMs myself. So actually taking data from a specific company or language or somehow group. And when you train an LLM on that data, you get a representation of that mind, which means you're able to see how are different concepts discussed. You can think about how does that relate to how those people behave. In many cases, this data are already there and contain a treasure trove of insights about those groups. So when we have this capacity now, we have more computing power than ever before to produce these representations of the mind. The question is, how are you going to use it? In this modern world, you almost can't afford not to leave all of those insights on the shelf and not try to benefit from them to understand ourselves and to understand others. So thank you very much for listening to me. This was based on two papers, this older one with these lovely people across the world, as well as the co-authors that I mentioned. I'm now very lucky that I'm going to be helped with questions by Robin Holloway, who is a current MBA at INSEAD, who I believe is heavily involved with the AGI Club, as well as working in product management. Forgive me, Robin, if I was wrong.
Nope, that's correct. Hi, everyone. I hope you enjoyed the presentation. It was really fascinating. We have a few questions in the chat here, and I would love to start for Asher. And the first question that we have is, how does the use of data generated by large language models affect biases in the publicly available data? Logically, this should amplify existing biases and misinformation. And are there any approaches being considered to counteract this and enhance fact checking and bias reduction?
Thank you.
That was a big one. Yeah.
Yeah, there's a few things in there. If I had a good answer to that, we would be in a better position. So I'll say a few things. The first thing is, I read a scary statistic the other day that something like 50% of content on the internet now is produced by LLMs. This is terrifying because we're in a position where we can produce content just at a rate never seen before. And we're sort of, regulation is so backwards looking that by the time we really know what to do about this, it's going to be sort of shutting the door after the horse has bolted. I think a key role of researchers and academics is to really sound the alarm bells of some of these risks. Because these private companies who have money on the line are very unlikely to do so. We saw with sort of AI ethics people that the second they start contravening profit incentives, they get fired. So it's quite difficult to think about some of these systemic risks. Second thing to note is there is some evidence that LLMs trained on LLM-produced content, this sort of recursiveness, where you try to continue improving from that synthetic content, is not very effective. So if you look at models that could produce great musical outputs from listening to actual real music, If you then try to train them on that fake music to make further music, it doesn't really work. So I think as we see this diminishing in the organic content, I think we run the risk of not having variance in the training data. If you think about something simple like a correlation, you need variance to be able to learn relationships, whereas if we're already just seeing outputs made by the algorithm that we have, we're not getting more variance, we're not getting more information, so it becomes difficult to continue to improve. As for misinformation, I live sort of in fear of when we'll really see this gearing up for the US election cycle and for some of the other global issues we have facing for us. I think, in my mind, the only solution that we have is going back to something like trusting reputable sources like newspapers. Because I also do research on misinformation, and what we've lost is this heavy valuing of source because we got this view that somehow sources are biased, and we started to get more and more of our news from social media, which democratized access to giving information and receiving information. But now, as we move into this world of deep fakes, I think it's simply not possible to regulate that at the speed that is necessary, and for those platforms to be able to filter through that content as well as to do so in a way that's seen as politically neutral, that we will get back into this world where the verification of content by newspapers, by bodies that we elect to do that is the only real way that we can counter this, where we need to stop trusting what we read on social media, because I just don't think doing this in real time is practical.
Great, thank you. So the next question we have is, what is your view about the fact that training LLMs and AI and Gen AI in particular is extremely energy intensive and consumes much more electricity than traditional data center activities? The fact that the demand for electricity, especially AI electricity requirements, is projected to be greater than what is currently available.
Yeah, so I mean, we saw something similar with Bitcoin. It's something stupid like 1% of US
Mhm.
electricity is used to mine Bitcoin. It's Would I have an opinion on it? I mean, it's difficult. I think you couldn't regulate that people use, I think, electricity for particular choices. So to some extent, I think it's infeasible to say we should somehow try to stop this, whether I think it's good or not. I think ultimately you have to see what happens in free markets. So the idea we reach a situation where there is no electricity because of LLMs, I'm not really concerned about that, because at some point it will become that electricity or for that use becomes so expensive that people become strongly incentivized to train those models more efficiently. And we're already seeing that a bit. So I mentioned it briefly on that slide about the large part of LLM, where at some point people were really expanding the number of parameters they tried to use. And then they sort of diverted from that and now already is starting to deal with this question of efficiency. Partly because the models become so large that even storing them or people downloading them is very difficult. But if we work towards these models that both can have fewer parameters as well as be trained more effectively, we're already sort of addressing that question of electricity use. But I think ultimately, sadly, that this will end up with market incentives. And so people will mainly get incentivized to do that if electricity becomes more expensive. So my personal views aside, I see this as something we can't really do anything about.
Okay, great, thank you. And this question is coming in from Erica. She is asking really about the injection of those arbitrary words into the prompts. Does that mean that large corporations who develop their own models, will they also heavily bias the outcomes? So for example, if McKinsey is creating an LLM or Salesforce is creating an LLM, how, from a B2B perspective, will that be moderated and managed? And is there risk there?
I think there's risk if we uncritically accept the outputs of models. What I'm concerned about is, so the early literature on sort of algorithm aversion found that people were averse to just wholesale accepting the outputs of analytical tools. And this was kind of okay because it meant, well, people viewed it as negative as the time because they thought people would be more accurate if they listened more to the algorithm. But it maintains this level of critical scrutiny where people are still thinking, and this is okay. What I'm worried about with LLMs is if you train a sort of custom LLM, it tells you a bit about yourself. So it kind of talks in a way that makes you comfortable. You stop scrutinizing those outputs and just accept what it says. This is very dangerous for that specific reason that these are not value neutral and these are ultimately private profit-making companies, which is a terrifying thing to some extent as we see them get more and more integrated with core functioning of society. To have that be privately owned is very complicated. But that said, if you think about a business having one, so Microsoft or McKinsey having a B2B one, you shouldn't trust that output just as much as you shouldn't trust a McKinsey consultant wholesale, right? It's clear that in this business strategic interaction, people have their incentives. So you should just treat it as any representative from that company that they're trying to optimize their function, you're trying to optimize yours. So you know that whatever you get from them is not a pure analytical answer that's in your best interest. It's some mixture of that and what's strategic for them. So to some extent, I don't view this as a risk because in these business, highly informed interactions, we know to be critical and we're sort of grounded in a truth. But I'm more worried is where people are using this for things where they're uneducated. Because, for example, ChatGPT is great for stuff like helping people write legal letters. But if you suppose it had some bias that it wrote these in a way that didn't actually get the maximum damages because they've been paid by big corporations, your individual user would have no means of detecting that because they're not informed on this issue. So when it's used in a business context, I think we're more informed consumers. But when we're using it to extend our capacities beyond the ability that we have to actually scrutinize this is when it's dangerous because we're sort of flying blind.
Great, thank you. So on that similar topic, this is coming from an anonymous attendee, but do LLMs in training already attach less value to information from social media and more value to things like newspapers, or is that completely determined by the company, and is that currently a bit of a black box by the uh, wider community?
Yeah, so as far as I know, there is no weighting function like that. I think that's a black box. So it's also not clear what is optimal there. Because if you think, what are you really trying to encode in an LLM? Is it just information or is it somehow understanding of how people think and how people talk? Essentially, all that you get in an LLM is actually how people talk. But as we've seen in some of the evidence today and in other places, it does seem that this proxies or at least contains information about how people think. But from this perspective, something like Facebook or Twitter, where you have lots of different people thinking and in a less structured, less sort of manicured way, is actually much more informative because you get more variance in how people are talking. Whereas if I train an LLM to try and understand internal processes based on a newspaper article, this gets me less insight into your mind because you've been very strategic in how you've wrote it, you've written it for a particular audience, and all these different things. So when trying to extract meaning or information from a section of text, I think the more strategically it's written, the more it's polished, the less useful it is. So it's not clear that it would optimize the functionality of those LLMs to do that, to upweight those good sources. What is clear that something like OpenAI is very good at this triage of stopping ChatGPT from saying bad things. So if you saw Bard when it came out, had all these high-profile disasters where it's regurgitating things that it read off something like 4chan. Whereas
Mhm.
OpenAI, through some method that's not quite clear to me, has very good triage on stopping it doing that. But it's still not exactly clear what we're even aiming for. Is the model's job to understand you or to guide you in socially constructive ways? And that's why it's so complicated that these are in the hands of private companies. Not that I think a government would do any better of a job, because it's not clear what that company's incentive is. What do they actually want to help you with? Well, they want you to pay for their premium version of the model, but whether that's by really helping your lifestyle or just feeding sort of your biases is much less clear. If you think about something like social media, the algorithm more sort of helps you perpetuate your negative tendencies. Something like TikTok throws you down the rabbit hole really quickly
Mhm.
because that's the maximum way to engage you. It could be that the LLM maximally gets you to pay their subscription by, reinforcing your biases rather than leading you to something good. And so whilst we're in this intermediate phase, it's just unclear what we're even trying to achieve. We just made this cool, shiny toy and we've thrown it everywhere and we can't take it back.
So on that same note, this again comes from an anonymous attendee. How do you think governments should respond? Should there be regulation requiring LLMs to disregard social media or Reddit or Fortran entirely, even though there's plenty of misinformation elsewhere on the internet?
It's a very complicated question because something that always irritates me is just how backwards looking regulation is. If you take blockchain, you take crypto, like pump and dump schemes that would be illegal if this were any other type of financial asset are absolutely ubiquitous in these spaces. So the problem is when we have this backwards looking regulation, it takes decades before we even know what we've kind of got a hold of. In the meantime, many people get hurt. But of course, we saw this recent AI bill. It's not that recent anymore. The AI bill in the US that tried to be sort of forward-looking and even made reference to particular numbers of model parameters. It's such an uncertain space that it's just very difficult to know what we should be regulating. I think for me, it's difficult to regulate exactly what's happening on the model side, partly because we just don't know. I mean, those models are using all types of copyrighted data that, as far as I'm aware, is just illegal, but because it's very hard to prove, they will do with impunity. But I think the area where we can try to regulate is on the consumer side. So on actually what is deployed that people use, what do we inform them about that, and making sure that the people don't sort of get to play with matches. And so I think it's very hard to say what the companies could do just because the technology is changing so much, but we can think about protecting our consumers.
Okay, great. Thank you. And then maybe a slightly easier question. Maximilian has asked, how did your research deal with the fact that many languages like English and Spanish are spoken in multiple countries with likely very different opinions about inequality?
Yeah, thank you. So this is something we had to address. So if you take English as spoken in England, USA, Canada, etc., when we're predicting the set of attitudes in that country, we predict with the same set of linguistic features from the language of English, and then we have dummy features for, this being Canada versus England, where you have an omitted category, which just takes the mean out. Um, it's not like we can introduce a new set of features, although maybe they slightly differ because there's a slightly different blend of languages. So we still see those relationships emerge in the presence of that. Theoretically, it would be quite interesting to study how English is used differently in different countries. I mean, I'm from the UK, I moved to the US. It certainly seems like a different language they speak over there. But that wasn't something that we actually studied in this project. So just dummy variables was how we did that.
Great, thank you. And then just one final question, because this one seems to be a popular one. You said that we should be critical. This comes from Arlette. You said that we should be critical and worry about who and why has changed the trained data, but how can we as consumers ever be aware of that?
Yeah, correct. So there's a very deep philosophical point. If you go back to sort of Plato's Republic, the idea of philosopher kings, essentially we have moved into an age where we now increasingly cannot exist without depending on AI, because to not use something like ChatGPT is to commit to being less productive than others, and in a competitive environment, you get killed. But these private companies who are able to train, deploy, and modify these models as they see fit have become these new philosopher kings who end up being social planners with unilateral power. And we see Sam Altman is just consolidating and consolidating power, who have the right to make those changes with sort of no oversight. And so indeed, as an individual consumer, you cannot know what went on behind the scenes there, but you know something went on. And so all I think we can do is just be highly critical of the outputs we receive and try to think about whether this is really aligned with what serves us or whether it's aligned with some different perspective. Of course, the difficult thing about this is there's a lot of hysteria at the moment about how things like ChatGPT and AI let us do things that we're not competent in. One of my advice would be don't use AI for anything where you cannot critically evaluate the outputs, which means actually to stick within your competency. Because the second you use something where you can't interpret it, you're falling asleep at the wheel. If you are trained in something, then you have this ability to scrutinize and it saves you time. But if you're not trained in something, then you're really just relying on these people to be benevolent philosopher kings, and I'm not sure that's a good assumption.
I'm glad I asked that last question because that was a pretty amazing answer. Thank you so much. I'll hand it back to you to say goodbye to everybody.
Okay, well, thanks so much for moderating, Robin. Thank you for a wonderful set of questions. It's really a pleasure and a privilege to be in the Tech Talk X series talking to you all again, as well as to hear some of these really important insights and things I think are the questions that are facing us as a society. I don't have answers, but hopefully, by thinking together, we can start to move towards at least some directions that might ultimately bring some. So thanks, everyone. You've been fantastic. It's been a pleasure, and have a great rest of your Wednesday.